All right, today's lesson, lesson 7.5, linear inequalities. A couple of definitions. A linear inequality is a region of a coordinate plane that has a boundary line. So let's look at that. If this is my coordinate plane, this is my inequality, this would be a less than, equal to, or greater than or equal to. Boundary means we shade it. The boundary line means it's shaded, meaning all of the solutions are in that shaded region, including the line. If you have the symbol less than or greater than, your boundary line is going to be dashed. It's going to be a dashed line. Okay? Each point in the region is a solution of the inequality, meaning this point would make that work, this point would make it work. Anywhere inside of here that is shaded, remember, including the line if it's solid. Okay, so anywhere in there would make those equations, or inequalities true. The solutions of an inequality are the coordinates of the points that make the inequality true. So I just said solutions are the coordinates of the point that make the inequality true. All right, so the steps. Step number 1, decide whether the line is going to be solid or dashed. Remember that if we have less than equal to or greater than equal to, the line is solid. And if we use less than or greater than, our line is dashed. Number 2, graph the line. Usually we graph lines using slope-intercept form or intercepts on the standard form. Okay? Cover up. You guys remember this probably by the cover up method. Cover up. Okay? Lastly, pick a point that is not on the line and substitute it into the inequality. If it makes the inequality true, shade that side. If it is false, shade the other side. So those are our 3 steps. All right, so example number 1. I need to graph this inequality. Remember, step 1 says find out if it's going to be a dashed line or a dotted line. So I need to look at this right here. Does this tell me it's going to be a dashed line or a dotted line? Or sorry, a dashed line or a solid line? Yeah, this is going to be a dashed line. Okay, step number 2 says graph. And we really know that it's pretty simple to graph our equations when they model this. And thankfully for us, our equation is already set up like that. So the slope of this equation is 3, and the y-intercept of this equation is -1. Remember, the y-intercept is where we begin okay? So I'm going to go to the y-axis at -1, and I'm going to plot a point. All right, and then my slope is 3. That's a positive 3. 1, 2, 3 over 1. I'm going to do that again. Up 1, 2, 3 over 1. One more time. Up 1, 2, 3 over 1. So now I have some very nice points. I need to remember that my line is dashed. Put arrows on the ends of my line. Okay? Step number 3 says pick a point. So we're going to pick the point, pick a point that's not on the line. Pick a point that's not on the line. So the point 0, 0 is not on the line, and that's the easiest point to pick. So we're going to plug that back into our inequality and see if it makes it true. So y is 0 is greater than 3 times 0 minus 1. Let's see. That means that 0 is greater than 3 times 0 is 0, minus 1, 0 is greater than negative 1. Is that true? Yes, it is. So I'm going to shade the side where 0, 0 lies. 0, 0 was this point right here. So I'm going to shade all of this. That means that the solution is anywhere in this side. Okay? Let's try another example. Example B, I need to graph, and this one is not in the form y equals mx plus b. Let's do step number 1. Is this going to be a solid line or a dashed line? Excellent. Yeah, it's going to be a dashed line. Okay? Step number 2, I need to graph this. So let's first of all solve for y. Okay? So I have 4x minus 3y is greater than 6. I'm going to subtract 4x from both sides. Remember, I'm going to keep my x term first. So I have negative 3y is greater than negative 4x plus 6. Now I have to divide every stinking term by a negative 3. Remember, I'm dealing with inequalities. What happens when you divide by a negative? Yeah, exactly. I need to flip that. So I have y is less than 4/3 x plus, it's actually negative 3 right here, plus or minus 2. Y is less than 4/3 x minus 2. So this equation, or inequality, tells me that my slope is a positive 4/3, and my y-intercept is negative 2. So remember, the y-intercept is where we begin, so I'm going to go over to negative 2, plot a point, and then I have the slope of 4/3. Up 4, over 3. Do it again. Up 4, over 3. Okay, solid line or a dashed line? Dashed. So let's go ahead and dash our lines. Okay, step number 3, I need to pick a point that is not on the line. The easiest point to pick always is 0, 0. So that's the ordered pair that I'm going to pick. So let's substitute that in. 4 times 0 minus 3 times 0 is greater than 6. That says that 0 minus 0 is greater than 6, or 0 is greater than 6. Is that true? No, it's not true. So I'm going to shade on the other side. I'm going to shade on the other side. So remember, when you pick a point, you plug it back into your inequality. If the point that you pick makes the inequality false, you shade on the opposite side of your boundary line. Okay? All right. Example 2. Suppose your budget allows you to spend no more than $24 for decorations for a party. Streamers cost $2 a roll, and tablecloths cost $6 each. Use the intercepts to graph the inequality that represents the situation. Find 3 possible combinations. Well, first of all, we need to remember what no more than $24 means. All right, so again, our equation, example 2, suppose your budget allows you to spend no more than, remember we said no more than is less than or equal to 24. We're going to let x equal the number of streamers. We'll let y equal the number of tablecloths. Let's see. So streamers are $2 each, so that's 2x. And tablecloths are $6 each, plus 6y has to be less than or equal to 24. I'm going to get my graph ready really fast. This is x, which is my streamers. This is my tablecloths. So it says use the intercepts to graph this. Well, intercepts, when I let y equal 0, or when I cover up y, I know that x needs to be 12. And when I let x equal 0, or when I cover it up, y has to be 4. So when I go to graph those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 0, 12 for streamers. 1, 2, 3, 4. This is, so 12, 0 for streamers, 0, 4, and it was a solid line because of the less than or equal to. I'm actually going to see if I can use my line tool so I get a nice straight line for us. That's excellent. That's even better. Okay. So that's perfect, actually. So that's where 12 was. This was 4. Okay, so the last part says to find 3 possible combinations of streamers and tablecloths. Well, I could buy 12 streamers. And if I do that, I have to buy 0 tablecloths. So that would work. What if I bought 1, 2, 3, 4, 5, 6 streamers? How many tablecloths could I buy without going over? Buy 1. So 6 streamers. So again, 1, 2, 3, 4, 5, 6. The only point that I can plot without going over my boundary line is the number of streamers, 6. The number of tablecloths would be 1. And what about if I bought 2 streamers? If I bought 2 streamers, I could buy 1, 2, 3 tablecloths. 2 streamers, 3 tablecloths. Okay, so those are just 3 possibilities. All right, example 3. Determine if point Q is a solution to the linear equality. So I have an inequality. Y is less than or equal to negative 2x plus 1. And I have point Q, which is the ordered pair 2, 2. So remember that this is an x and y. So all I do to discover if this is a solution or not is plug these 2 values in for x and y. So I'm going to let y equal 2. 2 is less than or equal to negative 2 times x, which is 2, plus 1. 2 is less than or equal to negative 4 plus 1. 2 is less than or equal to negative 3. Well, is that true? Is 2 less than or equal to negative 3? No, that is not true. So this is not a solution. Okay. Homework, page 337. You have 10 problems. Page 337, 10 problems. Most of them are graphs. I think that's it. I think these 7 are probably graphs. These 7s are probably going to be you graphing an inequality. And it might even be number 6 as well. Okay, I passed graph paper out in class, so there you go.